The other day we talked about a special property associated with the fact that exponential functions are one-to-one, and we saw that if a to the u is equal to a to the v, then u had to equal v. Well, we can actually write down a similar statement for logarithms. So once again, it's because logarithmic functions are one-to-one, we can say that if log base a of m is equal to log base a of n, then m had to equal n. So we can use that in lots of different ways. Let's go ahead and check out example 6 to see one way where we can use that particular process. So here we have natural log of y is equal to 2 times the natural log of x minus the natural log of the quantity x plus 1 plus the natural log of 5. So in order to use this rule that we just saw a moment ago, notice what we have. We have one log piece on the left-hand side and one log piece on the right-hand side. I have one piece on the left-hand side, but I have too many logs over on the right-hand side. I have 3 log pieces on the right-hand side. I only want 1. So go back a couple of examples. We had an example just a moment ago that said, hey, if you have a whole bunch of little logs, you can bring those little logs together as one big logarithmic statement. So in fact, this is just a review of a problem we looked at a moment ago. Let's go ahead and take all these little logs and bring them together as one big log. Then we can use this property from the top of the board. So, okay, first thing I remember is that I have to use the order of operations, and I need to think about any constants that are hanging out in front. I need to work with my exponents before I do anything else. So this 2 is going to go up as my power. So it's going to be the natural log of x squared minus the natural log of the quantity x plus 1 plus the natural log of 5. Next off then, I notice that I have a whole bunch of logs connected by additions and subtractions. I do them in the order that they appear from left to right. So I have a subtraction first. So if I have that subtraction first, I know that there's a connection between the subtraction of logarithms and the division of their arguments. So this is going to be the natural log of x squared divided by x plus 1. Next off then, I have natural log of somebody plus natural log of somebody. There's a connection between addition and multiplication. So this is going to be the natural log of y is equal to the natural log of, remember 5 can be thought of as 5 over 1. Bring this 5 in when I do the multiplication. Multiply numerator times numerator, denominator times denominator. We're going to have 5x squared divided by x plus 1. So my goal here was to get this written in a form that I could use this particular property. And in order to make that happen, I had to have one log on the left and one log on the right. That's where we are right now. So I have log on the left equals log on the right. The other thing that I have to double check in order to use this particular idea is that the base of the log is the same on the left and the right. And yes, it is. I have log base e on the left and I have log base e on the right, so we're good for using this particular property. So, one more time, if I have a log on the left equaling a log on the right, the only way that those can be equal, if the bases are the same, is if the arguments were equal. Well, okay, so I have a log of an argument equals a log of an argument. That means then that the only way that this can be true is if y, the argument from the left, is equal to 5x squared divided by x plus 1, the argument from the right. Now, as you look at what just happened, we've actually accomplished what this problem asked us to do. This problem said, express y as a function of x. Expressing y as a function of x means that we're really going to be solving for y. And we need to make sure that there aren't any y's still running around on the right-hand side. So if you look at what I just wrote down, both of those things are happening. I've solved for y, and there aren't any y's running around on the right-hand side. So this is the final answer for this particular problem. Y is equal to the fraction 5x squared divided by x plus 1. At this point, you're set to go ahead and check out all of the homework associated with this section. Have fun!